Yeah. So good evening, everyone. Good evening. Good evening, everyone. Yeah. Good evening. Good evening, everyone. So can we start? Can we start? Yeah. Good evening. Good evening, Abhijit. Good evening. Good evening, Sai. Good evening, everyone. Can we start the lecture too? Am I audible? Is everything is okay? Can we start? Is everything is okay? Can we start? Can we start? Is everything fine? Can we start? Where is Hayden? Hayden, where are you? Good evening, everyone. Hayden, where are you? Hayden, where are you? Devadrita came, Neha came, Anish came, Sai came. Where is Johan? Where is Johan? Neha came, Jay came, Akanksha came. Game came, Shakir came. Yeah, let's start now. Let's start now. Right, I'm starting now. I'm starting compiler design lecture 2. Compiler design lecture 2. Compiler design lecture 2. Yeah, I'm starting. Everything is okay. I'm starting. In the last class, we seen some introduction. So now we'll see, right, actual story. Now we'll see introduction to compiler. Now we will see today, in today's class, we will see introduction to compiler, right? So to the lecture number 2. Yeah. So as I mentioned to you, everyone know, so just give me 1 minute. Yeah. So as I mentioned to you, just let me say a little bit about this. One new batch is starting. Yeah, one new batch is started. I think one day only over. Those people who are serious about GATE examination. If you are serious about GATE examination, if you are serious, you can join in this batch. In this batch, you can join. So you will get the 25% discount. You will get 25% discount if you are serious about the GATE exam. You can join in this batch. Just go to ExamPrepTool.com. There you can buy this course. right? 2025 people, 26 people, 27 people can take this, right? So let's go to next one. EPT daily quizzes are going on in the EPT Telegram group. In the EPT Telegram group, EPT daily quizzes are going on, right? I hope you will utilize this. If anyone is not there in the EPT Telegram group, right? So yeah, just ping us, we will add you, or go to our website, you will find the link also from there. Next one, DSA 30 days challenge is going on, right? 30 days, 30 difficult questions of DSA will be given with the algorithms, right? You can utilize this also. DSA challenge also you can take care. DSA challenge also you can take care. Next one, right? If you want to be good in the DSA, right? So there is a DSA course for placements, you can go for that. Or if you want to be good in the web development plus DSA, web development plus DSA, you can go ahead. App development plus DSA, you can go ahead. So these three courses, anything you can join. Anything you can join. So you can go for GATE CSE, GATE DA, GATE CSE plus GATE, right? GATE CSE plus DSA, GATE CSE plus DA, right? So you can go for the crash course, whatever you feel, right? Rank improvement course there, you can utilize all, right? Now let's start. Now let's start the today's class. Let's start the today's class. I'm starting. Write down now. Topic name, today's class. Can you say the date? Date is, I think, 22. 22/07/24. 22/07/24. So the topic name is Introduction to Compiler. Be careful, everyone. Introduction to Compiler. This is the topic name. Yeah, get everything. 22/07/24. So in my opinion, today is the first class. In my opinion, today is the first class, right? I'm starting now. Everything is ready. Everything is ready. 22/07/24, Introduction to Compiler. So I'm starting now. So as I mentioned to you in the last class, can you see this one? Compiler is a software. Compiler is a software. When you say software, it is a program. Compiler is a software, so it is a program. So, and one more thing is, it's not only a program, it's a very big program. It's a very big program. So there are so many functions. So many functions are there. Many functions are there. So as I mentioned to you, functions, right? Functions also I written. So let me write now. Lexical analyzer is the one function. Syntax analyzer is the one more function. Semantic analyzer is the one more function. Intermediate code generator is the one more function. Code optimization is the one more function. Target code generator is the one more function. So this is the compiler. Input is high level language. Output low level language. And while doing this at anywhere, if you have any problem, you can contact error controller. Next one, whenever the story going on, at anywhere if you want to store, you can store in symbol table. You can store in symbol table. This is what we discussed in the last class, right? Topic is Introduction to Compiler. That's the topic name. Introduction to Compiler is the topic name, right? So compiler is a software which is a big program. When you say big program, many functions are there. So these are the function name. lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimization, target code generator. Anywhere, any problem, contact error control. At anywhere, if you want to store anything, store in symbol table. Now my first question to everyone. Please give answer. Now my first question to everyone, please give answer to me. Who can store inside symbol table? My first question to everyone, please give answer. Who can store inside symbol table? Who can store inside symbol table? Lexical, syntax, semantic, intermediate code generation, code optimization, target code generator. Who can store? Make it fast. Who can store inside symbol table? These are also called as programming terminology. These are called functions. Programming terminology, these are called functions. In the compiler terminology, these are called as phases of compiler. These are also called phases of compiler. Phases of compiler are functions which are there inside a compiler. Phases of compiler. So can you help me now? Who can store inside symbol table? So remember everyone. Who can store is anyone. Whether they will store or not, it is a different story. Anyone can store. If at all there, select the all option. If at all there, select all option, because everyone having right. Whether they will do or not, it is a different story. Next one, who can inform the error handler? Anyone. Everyone having right. Everyone having right. In this classroom, who can ask doubts? In this classroom, who can ask the doubts? Everyone. Some students may not ask. But everyone having right. Who can ask the doubt is everyone. So see the direction also. See, everyone going to symbol table. Everyone going to the error handler. Whether they will do or not, it is a different story, right? They have right. Everyone having right. Everyone having right. Whether they will store or not, it is a different story. But everyone having right. If at all option there, select all. All option there, select all. Right. Okay. You are a little bit comfortable. Now let's see how exactly going on inside. Let's see that. How exactly going on inside. Everyone see how exactly going on. Let's take one example. And we'll check here. Right now. Today's class, this is the major one. X is equal to y plus z star 60, some number. X is equal to y plus z star 60. Right? And one more, before, actually it is not required. I'm just only for namesake I'm writing. Float x comma y comma z. Declaration also there. Float x comma y comma z. X is equal to y plus z star 60. X is equal to y plus z star 60. Right? Before going to use any variable, you have to declare I declared. Before going to use any variable, I have to declare I declare. But my goal is only this statement. My goal is only second statement, not first statement. My goal is only second statement, not first statement. Now listen everyone. Everyone listen. So before going further, I want to ask you, please help me. What is the X data type? Please let me know what is the X data type. It is a sequence number. It is a variable name. It is a variable type. I want answer from everyone. What is the X type? What is the Y type? What is the Z type? I want everyone respond. What is the X type? What is the Y type? What is the Z type? Everyone know. Please respond. Any doubt there, you can ask me. Right? X type, Y type, Z type. I think everyone now X type is float. How you know? Because of declaration. Because of declaration only I got to know X type is float, Y type is float, Z type is float. Because of declaration only I got to know. Now can anyone help me? If declaration not there, can you say what is the X type? If declaration not there, I cannot say what is the X type. If declaration not there, I cannot say what is the Y type. If declaration not there, I cannot say what is the Z type. Right? So these are all the people types I got to know because of declaration only. So because of declaration, listen, because of declaration, I got to know X type is float. So see this one, everyone. One, variable is X, type float. Two, serial number two, variable name is Y, type is float. Next one, variable name is Z, type is float. Type is float, like this. Now some people are asking, sir, what is the name of these tables? Are symbol table. Symbol table. This is called symbol table. Now, one more thing I want to ask you. Can anyone help you now? Symbol table came. Symbol table came because of declaration or not? Symbol table came because of declaration or not? If declaration is not there, how I know X type is float? If symbol table is, if declaration is not there, how I know Y type is float? If symbol table is not there, how I know Z type is float? Because of declaration only the symbol table is came. You only say symbol table not there. Sorry, you only say declaration not there. Right? What I will store inside symbol table. So remember everyone. From today onwards, remember everyone. In the symbol table, if you observe X type float, Y type float, from where it came? From declaration. If declaration is not there, from where I know X is a float? Because of declaration only that symbol table story came. Now, one more important thing I want to say to everyone remember. One more important thing I want to say everyone remember. Symbol table contain variable names. Symbol table contain variable names. Symbol table contain function names. Symbol table stores variable name. Symbol table store function name. User defined variable, user defined functions, which are known as identifier. User defined, right? User defined variables, user defined functions. These are known as identifiers. These are known as identifiers. Remember, symbol table stores identifiers. Symbol table stores identifiers. From today onwards, if anyone asks you, symbol table stores what? Identifier. What is the identifier? User defined variables, user defined functions. Those are known as identifier. They will be there in the symbol table. Now, one small question I want to ask you. Everyone listen. Everyone listen. In the program, user can give the variable name whatever he want or not. Whenever I am writing a program, user can write the variable name whatever he like. User can write the function name whatever he like. Whatever variable name you want, he can write in the program. Whatever function name you want, he can write. The reason is there is no fixed thing. Any variable name you can write, any function name you can write. Because of anything he is writing, so definitely there should be one place where they will store. Because when you write blindly something, there should be some management. If that management is not there, it is a serious issue. Because these are not predefined names. These are the user-defined names. Right? The person who written the programming language is given he is given the flexibility to the user. You select whatever name you like. We will take care. The person who written this programming language, he said that whatever variable name you want, you can take. Whatever function name you want, you can take, because we will take care. You take whatever you want, we will take care. How they are taking care? They are taking care in the symbol table. The inventor of this programming language saying that you take any variable name, you take any function name, because we will take care. Right? You no need to bother. You want to take any variable, you want to take variable name as X, you take. You want to take variable name as X, Y, Z variable name, you take. We will take care. Now it is a correct time to ask you. Listen, it is a correct time to ask you. Everyone listen. It is a correct time to ask you. User can take whatever keyword you want or not. I want answer from you. I want answer from everyone. User can take whatever keyword he like. No, keywords are predefined. Those only you can take. Keywords are predefined. I can take, see, keywords are predefined. Those only I can take. So can I take the keyword if? Yes. Can I take the keyword return? Yes. Can I take the keyword into? Yes. So I cannot take whatever keyword I like. Whatever is available, out of them I can select. But variable name, you can select whatever you want. Whatever you feel, you can write. I can take variable name as hidden. I can take variable name as Shakir. I can take variable name as Neha. I can take variable name as Akanksha Neha. I can take variable name as Manish. I am saying one more thing. I can take variable name, go to hell. I can take variable name, go to hell. I can take variable name, God is seeing from top. You can take whatever you want, but keywords, you cannot take whatever you want. Now, last question I want to ask you. Variable names are fixed or not? No. User, right? Next one. Function names are fixed or not? No. So can I take whatever I want? Yes. Then where they will be managed? In the symbol table. Next one. Can I take whatever keywords I want? No. Keywords are fixed. Can I take whatever operators I want? No. Operators also fixed. Operators also fixed. What I want to say is keywords are fixed. Next one, operators are fixed. Boolean operators are fixed. Relational operators are fixed. Arithmetic operations are fixed. Logical operators are fixed. What I mean to say is, except variable name, function name, everything is fixed. So symbol table contain user-defined variable, user-defined function. The things which are given by user, they will store in the symbol table. Some people are asking, sir, where because of operators are fixed, keywords are fixed, sir, where they will store, sir? They will store in, if it is a C language, Turbo C compiler. Inside compiler, it will store. Inside compiler, they will store. You only say compiler is a software. When you say software, it will store in some database. In that database, all the operators will store. All the keywords will store. Are you getting? When you say Turbo C compiler is installed, when you say compiler is installed, what is the meaning of compiler installed? Compiler is a software. Software is installed means indirectly that software is saying to your computer, these operators only allowed. These keywords only allowed. Remember, compiler is nothing but some conditions. Compiler is nothing but some rules. One rule is saying that these operators only have to use. Compiler is nothing but set of rules. Compiler is nothing but set of rules. Those rules are saying that these operators only you have to allow. These keywords only you have to allow. Some rules are there. So one of the rule is these operators only. One of the rule is these keywords only. But in terms of the variable name, you can select whatever you want. In terms of the function name, whatever you want, you can select. So last question I want to ask. Someone is saying, but float is a keyword, of course. Float is a keyword, right? So you can say it is a keyword, it is a data type also. Keyword, you can say data type also. All predefined things are keywords, right? So in that some special category. In that if is a keyword. If is a keyword. Return is a keyword. Break is a keyword. Continue is a keyword. Main is a keyword. Print is a keyword. Some predefined things. User-defined variable, user-defined function, they will store in symbol table. Next one, plus is a operator. Star is a operator. Next one, right? So one more thing is R operator. Bitwise and operator, they are operators. They are operators, right? Fine. So, and one more thing is float is a data type. You can say keyword also. They are data types, right? Actually, Actually, int is a data type. Actually, int is a data type. If you want, you can say keyword also. But when you are studying in the C language, you will study data types. That is also keyword kind of thing, but separate thing. So that is going to be what the answer? Data types. Data types. If is a keyword, star is a operator. So like that. Okay, fine. Okay, whatever you got, it's okay. Last question. Everyone comment in the comment section. Everyone comment in the comment section. What will store in symbol table? Comment. Make it fast. What will store in symbol table? Everyone. What will store in symbol table? Everyone. Make it fast. Identifier. What is the meaning of identifier? Type that also. What is the meaning of identifier? Symbol table contain identifiers. I am very happy. What are the identifiers? User defined variable, user defined function. User defined variable, user defined functions. Identification purpose only names. User defined variable name, user defined function name. Identification purpose only. Identification purpose only. Next one. Can you help me now? Operators will store inside symbol table. No. Then where they will store? They will store inside compiler. Compiler is a set of rules. One of the rule is these operators only. One of the rule is these keywords only. One of the rule is these operators only. One of the rule is these keywords only. Right? So please be careful. Right? See, the things which are not there in the symbol table, they will be there. They will be there inside compiler. That is the meaning of compiler. Compiler is installed. In my computer, compiler is installed. Indirectly, your compiler is saying to your computer, these operators only allowed. These keywords only allowed. Something like that. Okay, fine. That's okay. Now listen. Everyone. Everyone listen. Careful, everyone listen. So, because of this declaration, I'm saying clearly, because of this declaration, this table came. Because of this declaration, this table came. Right? Because of this declaration, this table came. Try to understand. Right? This declaration only, this table came. Right? Now you may say that, sir, who stored? Remember everyone. Right? So afterwards I will confirm. Because of this declaration only, this table came. Who stored it? Right? I'm saying now semantic analyzer. Who stored it? Semantic analyzer. Afterwards I will say why. But one thing I want to say to you, everyone can store inside. Listen, every phase of the compiler can store inside a symbol table. Depending upon their requirement, they will store. Depending upon their requirement, they will take. Everyone can store, right? I can guess because of a lot of experience I have. So I can guess, right? By seeing the declaration, semantic analyzer will store in symbol table. You got to know. X is a float. Y is a float. Y is storing. Afterwards, I will say that also. By seeing the declaration, semantic analyzer will store the total information, whatever there in the declaration, inside symbol table. But remember, this is not our goal. Our goal is this line only. Now I am starting. Everyone listen. Now I am starting. From now onwards, careful. Remember this. This also remember. Semantic analyzer stored this data. By seeing this declaration, semantic analyzer stored inside the table. Remember it. Whenever correct time, I will ask you. At that time, you have to give answer. Now come back. Now see this one. This is our major line. So this particular line, if I give to compiler, what will happen? Let me check. Our goal is only this line, not first line. Second line only our goals. Remember everyone. This is the input to first phase of the compiler, which is a lexical analyzer. This is the input to first phase of the compiler, which is the lexical analyzer. The statement will be given as input to the lexical analyzer because it's the first phase of the compiler. Is the first phase. Someone is saying that, sir, does this mean that if some invalid variable name is kept by user, then it is checked by semantic analyzer or semantic analyzer? You will see anyhow. That Aditya, you will see anyhow, right? You will see anyhow. Don't ask me, it will disturb the other people. Don't ask anything, right? At the end, you will get the clarity. At the end, you will get the clarity. If I say now, some confusions will come. Concentrate here. So x is equal to y plus z star 60. This will go as input to the lexical analyzer. Is the first phase of the compiler. Lexical analyzer is the first phase of the compiler. Try to remember. You cannot expect great things from the first phase. From the first phase of the compiler, you cannot expect great things. So what I mean to say is the first phase. Maximum introduction will be done. First phase of the compiler cannot do everything. You will do most probably introduction. What is the introduction? See this one. Listen everyone now. Lexical analyzer will ask the X. Lexical analyzer will ask the X. Hello X, can you introduce? Hello X, can you introduce? Right? X will say, listen, X will say, I am a identifier. Remember, lexical analyzer purpose is some introduction, right? Everyone will introduce like this. So X is an identifier. You will say X is an identifier. Lexical analyzer is asking every person, can you introduce yourself? Lexical analyzer asking every person, can you introduce yourself? X is saying that, hello lexical analyzer, my name is X, I am an identifier. Then immediately lexical analyzer will say that if at all you are identifier, you should be there in the symbol table. Lexical analyzer is asking the X, hello X, can you introduce yourself? X is saying that, hello lexical analyzer, my name is X, I am an identifier. Immediately lexical analyzer will say that if at all you are identifier, you should be there in the symbol table. So he will verify in the symbol table which row is available. First row he will verify, second row, third row, like that he will check until he will find out. He find out in the first row itself. Yeah. So lexical analyzer will inform to X saying that, hello X, you said that you are an identifier. You should be there in the symbol table. I verified also. You are there in the symbol table first row. Then he will say that, yeah, from now onwards, if anyone asks, hello X, if anyone asks you from now onwards, my request to you is, please give this token number. This is the token number. This is your token. From now onwards, if anyone asks you, please give this token number. The purpose of this token number is X is an identifier. It is there in the symbol table first row. X is an identifier. It is there in the symbol table first row. If anyone asks you from now onwards, hello X, what are you? Who are you? So don't say I am this, I am that. Just give this token number, they will get to know. Just give this token number, you will get to know that. Right? Fine. So it is something like this. You went to the one of the hotel to eat the food. You went to one of the hotel. So you went to the ticket counter, right? You paid the bill also. They given one token. Whenever you have token, you no need to introduce yourself. Just give token number. If token is not there, they will ask you, right, what you are going to eat, right? So how much you are going to eat. You like this or not, you like that or not, some discussion. When you have a token number, just show token number inside that particular, right, inside that particular hotel, automatically they will get to know, is this, is that. They will get the clarity. So X is the identifier, its token number is ID, 1. Next one, after X, equal is coming. Can anyone help? Can anyone help? Can anyone help? C compiler knows about all C language operators or not? C compiler knows about C language all operators or not? Make it fast. C compiler knows about all C language operators or not? Because of he knows, right, C compiler knows about all C language operators. Every compiler knows what operators it is having. That is the reason, right? Whenever it is came, he got to know that it is a operator. Which operator it is? Assignment operator, yes. So you got to know it is the assignment operator. It is the assignment operator. And one more thing is, because of this person known to everyone in the compiler, everyone knows this person, because in the compiler database itself, right, all the operators are allowed. Because of he is known to everyone, no need to give token. Always remember, only new people token is given. Only new people token is given. For every person, no need to give token. New people only token. For every person, no need to give token. So if you want, you can, if you want, you can check one time. If you want, you can check one time. Right, inside your house, there is no token to mama saying that I am mama, I am Shakir mama, I am Neha mama, I am Reddy sir mama. Like that, no tokens are there. Known people no need to have token. Unknown people only token. Variable name, user can take whatever he want. Any name he can take. So for user defined variable, user defined function, token name is required, token number required. For the known things, no need to do token number. What is the requirement of, so Papa having token, I am Reddy sir Papa, I am Reddy sir Papa, I am Hidden Papa, I am Vipul Papa. What is the need of this? Known people, no need of token. So in the Vipul house, Vipul Mama saying that I am Vipul Mama, right? Vipul Papa is having the token, I am Vipul Papa. Vipul is saying that I am my Mama Papa's son. I am my Mama Papa's son. So like that, what is the total family tokens or what? Total family tokens. Are people don't have common sense. Total family tokens kya yaar? Everyone in the Vipul house is Chota brother. If Chota brother is having the token saying that I am Chota brother of Vipul, I am Chota brother of Vipul, why yaar? Total family tokens. Don't you think it is so bold? It is a nonsense. So only for unknown people. So one student asking in one of the class, Reddy sir, you given token to X. You given the token number to Y also. Why don't you give to assignment operator also? Why don't you give for operator? Array man, compiler knows about operators. Compiler knows about the keyboard. The things which are new people give token number. New people give token number. So old people, you don't need to give. So I think there is no token number for assignment operator. By seeing this one, compiler got to know that, lexical analyzer got to know that. See, whenever you say compiler, some people are asking, compiler means what, sir? Compiler means these people. Compiler means these people. Whenever compiler see assignment operator, compiler means these all people. So everyone knows what is assignment operator. Everyone knows. But everyone don't know user-defined variable. Everyone don't know user-defined function. But everyone knows what is the C language operator, what is the C language keyword. Everyone knows. Because of they knows, they don't give any key, any token. So I think this is the token number. Next one. I think after assignment operator is over, Y came. Y is saying that, right? Lexical analyzer is asking, hello Y, can you introduce yourself? Y is saying that I am a identifier. Hello lexical analyzer, I am the new person, I am a identifier. Immediately will say, if at all you are identifier, you should be there in the symbol table. Let me go and check. I think he verified. In the second row is there, he will say your token number is ID, 2. So from now onwards, if anyone asks you, right, why can you introduce yourself and all, you no need to say, just to show this token number. That is the reason in the college also, when you join first day, college people will give, right, identity card, which is the token. Whenever you join the college, first day of the college, they will give the identity card. They will give token number. Next time onwards, if in the college anyone asks you anything, who are you, right, why you came inside the campus, just to show token number, just to show identity card. In the college also, first day of the college, right, I think introduction will be happened. After introduction is over, they will give token numbers, because in that college these all people are new people. Because of they are new people, they, after introduction is over, they will give token number, which is nothing but identity card. Everyone having identity card. Everyone having identity card. So, right, I think lexical analyzer is asking the Y. Hello, Y, can you introduce? Immediately Y said that I am identifier. Immediately lexical analyzer said that if at all you are identifier, you should be there in the symbol table. Let me check. Oh, he is there. So your token number is ID, 2. Next one, plus came. Plus, whenever plus is came, lexical analyzer is saying that, hello, plus, you are my best friend because I know you very well. Whenever plus came, lexical analyzer don't have headache. Oh, plus, you are my family. I know you very well. So what is the answer? It is a addition operator. It is the addition operator. You got to know. Hey, plus, you are addition operator. I know very well. Yeah, no token number. Next one, Z is came. Immediately Z saying that I am an identifier. Immediately lexical analyzer will say, if you are identifier, just wait, I have to check in the symbol table. In the symbol table is right, in the symbol table is available. I think identifier. So ID, 3. Sir, semantic phase only created table. Just shut up. Are you hidden? Just shut up. You just shut up first. Are you getting? You just shut your mouth. Aditya also asked, if you don't know how to shut your mouth, if you don't know, ask Aditya. You don't know how to shut your mouth? Ask Aditya. Aditya also asked the same question. I said to Aditya, shut your mouth. He shut his mouth, right? If you don't know how to shut, ask him. Ask the Aditya. Aditya will help you. Arey, hidden, it will come. It will come within few minutes. It will come within few minutes. Don't divert the topic. Don't divert the topic. It will come within few minutes. One nice story going on. Please enjoy. Please enjoy one nice story going on. Just keep listening. All doubts will be clear. Good boy. Good boy. Good boy. He's a very good boy. He got now. If that is the case, Are Gootle, how you asked me previously? 10 minutes back, you asked me same doubt. Why you asked me? Now you are saying like a Rushi. Now you are saying like a Rushi or Muni. Like Rushi or Muni, you are saying. Just keep listening. All doubts will be clear. Now he is saying like a Muni or Rushi. Don't you know this before? Gootle. Because of you only asked this. Anyhow, thank you so much. Thank you. Within few minutes it will come. Within few minutes it will come. Don't worry. Now come here now. So Z is came. What is the next? Oh, good boy, good boy. Okay, can you listen? Can you listen, Bhaiya? Bhaiya, can you listen? Can you listen, Bhaiya? After Z, star came. So I think lexical analyzer got to know star. Oh, star. Your multiplication operator. Yeah. So what is the answer? Operator. What is the operator? Multiplication or maybe pointer, whatever it is. Multiplication operator. Multiplication operator. Multiplication operator. So no token number. Next to 60. After star 60 came. So what is the answer? Constant. It is a constant. It is a constant. So you got to know 60. So number means constant. So final conclusion. Listen, at the end of the story, I want to ask you one more thing. Can you help me now? To whom token number given? Say finally. At the end of the story, I want to ask you one thing. To whom token number given? Give answer first. At the end of the story, to whom token number given? What is the answer? Identifier. The people who are there in the symbol table. The people who are there in the symbol table, for them token number given. For them token number is given. So careful. For them token number. Now listen, one more thing. At the end of the story, listen, at the end of the story, your expression, the expression what you written. See, this is the expression. Careful, this is the expression. At the end of the lexical analysis, the story will be like this one. X means ID1. From now onwards, X means ID1. is equal to y means id2 plus id3 star 60. Some music is going on, right? Beside my house, some music is going on. Are you able to hear my voice or music? Some music is going on, right? Are you able to hear my voice or music? Which one you like more? Which one you like more? Which one you like more? My voice or music? My voice. Good boy. Your voice itself is music. Arey, there is a butterman. I can only hear your voice. There is a one butterman is there. He will say buttering is going on. He will say buttering is going on. One butterman is here. He cannot digest. If someone will praise me, that butterman will not digest. If someone is praising me, that butterman will not keep quiet. He cannot control himself. He cannot control himself. Immediately will say buttering is going on. Anyhow. So at the end of the lexical analyzer, so this is the thing which is going to come. Now it is a correct time. Listen, everyone listen. Almost we done it. From now onwards, if anyone asks you lexical analyzer, what is the input? Everyone listen. From now onwards, if anyone asks you lexical analyzer, what is the input? What is the input? Remember, high-level language statement, or high-level language string, or high-level language program. Right? Lexical analyzer input is going to be high-level language statement, or high-level language string, or high-level language program. You can say like this. Output is going to be token string. Output is going to be token string. With the tokens, we will write. Output is going to be token string. If you want, you can write token program. If you want, you can write token statement. Input is high-level language statement. Output is token string. Input is going to be high-level language statement. Output is token string. Only for identifier token number given. For all the people, no need to give. Inside family member, what is the need of giving tokens to everyone? Only new people token number. Inside the symbol table, see the way of asking question in the GATE examination. What symbol table contain? The way of asking questions in the GATE examination. The way of asking questions in the GATE examination. Who will be there inside symbol table? Identifiers. Who are the identifier? Right? I think identifier who are means user-defined variable, user-defined functions. User-defined variable, user-defined functions. Next one, lexical analyzer. What is the input? High-level language. Output, token string. Output is token string. Why is not given token to everyone? Known people you don't give token. Unknown people you will give token. Can we say from now onwards? Listen, from now onwards, other pages. Listen, from now onwards, other pages will see XR ID1. From now onwards, other pages will see XR ID1. From now onwards, other pages will see XR ID1. Which one? From now onwards, other pages will see XR ID1. Make it fast, yaar. XR ID1. ID1, token number. From now onwards, people will see token number only. Suppose assume that, listen, what is the use of token number? Listen, can you say one small line? My token number is ID1. Means what is my name? Can anyone respond? My token number is ID1. My token number is ID1. Then what is my name? So they will go, listen, my token number is ID1. What is my name is ID1. Oh, symbol table first row. They will go symbol table first row. My token number is ID1 means 1. Oh, in the symbol table first row. They will go first row. They will see variable name is X, variable type is float. That's the purpose of token. If token number is there, total information I will get to know. If token number is there, total, that's the purpose of token. Purpose of token number is identification. If someone will say my token number is ID1, I will go to symbol table first row. I will get to know variable name is X, variable type is float. Like that I will get to know. That is the purpose of token number. Now listen. Now listen. Everyone listen. Everyone listen. For after this phase, X going or ID1 going? After lexical analyzer, X going or ID1 going? After this phase, X going or ID1 going? What is the answer? X, right? I'm repeating once again. After this phase, X going or ID1 going? ID1 going. ID1 going. If anyone want to know what is ID1, directly they will go to the table first row. They will verify. Now it is the correct time to ask you. It is the correct time to ask you to know about X. Other people and lexical analyzer, who is taken more time? To know X information, other pages and lexical analyzer, which taken more time? To know X information, other stages or other pages or lexical analyzer, who is taken more time? To know about X clearly, other pages and lexical analyzer, who is taken more time? Lexical analyzer, because you have to check total table. Where is X in the table? Where is X in the table? Total table you have to check. Worst case, X may be there in the table last place. Best case, X may be there in the table first place. So lexical analyzer doing scanning like this, right? Whenever X came first time, lexical analyzer asking everyone, are you X? Are you X? Are you X? It is keep on asking. So lexical analyzer, by taking lot of time, so worst case, total table you have to check. Assume that n time. Worst case, by taking n time, is given the token number. But other people got to know about X information immediately. Other people taking constant time. Now it is the correct time to ask you, is lexical analyzer simplifying other pages of compiler or not? Is lexical analyzer simplifying other pages of compiler or not? Of course. If lexical analyzer don't give token number, other pages, all you have to check inside table. Right? First phase of the compiler, lexical analyzer, is taken n time, is given token number. Other people are using it. Other people will take constant time. They are happily utilizing the work which is done by the lexical analyzer. If lexical analyzer don't do, everyone will take n time, because everyone have to check the total table. If lexical analyzer don't check, other people have to check. So lexical analyzer simplifying the other phases of compiler. So in every family, listen, in every family, if the elder son or elder daughter, if they are good people, in every family, elder son or elder daughter, if they are good people, they will simplify younger son or younger daughter life. In every family, elder son or elder daughter will do good work. Assume they are doing good work. They are good people. They are indirectly simplifying, right, younger son or younger daughter life. If the first person itself is a buffoon, in every family, first person itself is a buffoon, over. They will die. Younger people will die. Younger people will die. If the first person itself is a buffoon, if the first person is a pig, in some families, elder son itself is a pig. In some families, elder daughter itself is a pig. They will indirectly create trouble to the younger people. They're indirectly trouble to the younger people. So, first person is doing good work. Other people can use it. Other people, I think people is the elder person. I think people is the elder person. Is feeling so bad. People feeling so bad. He's the elder one. I am saying that the elder people are buffoon. I am saying elder people are pig. I am saying. So he is feeling so bad. He is feeling so bad. Anyhow, I think you remember total story. Whatever happening, all the people remember. All the people are remembered. Now come to the next story. One small story. Listen, one small story. Everyone listen. One small story. Be careful everyone. Be careful everyone. One small story. One small story. Just I want to know one small story. Be careful. What is, listen everyone. If anyone asks you from today onwards, what is the lexical analyzer responsibility? What answer you are going to give? From today onwards, if anyone asks you lexical analyzer responsibility, what is the answer? Dividing the given program into tokens. From today onwards, if anyone asks you lexical analyzer responsibility, dividing the given program into tokens. Dividing given program into tokens. Dividing the given program into token. High level program to tokens. Another way of saying dividing the given program into tokens. Dividing the given program into tokens. Please be careful. This is the expected question in the exam. In the exam, they will ask you lexical analyzer purpose. Dividing given program into tokens. Dividing given program into tokens. Because of he's clearly saying, listen, he is clearly saying it is the identifier. It is a operator. Right? It is the identifier. It is the addition operator. It is a multiplication operator. It is a keyword. It is a constant. Because of he is clearly dividing. So another name for the lexical analyzer. Another name for lexical analyzer. Right? Another name is going to be, right? Lexical analyzer, another name. It is also known as scanner. It is also known as scanner. Because it is scanning the program. It is also known as scanner. Because after scanning program, it divides the program into token. It is also known as scanner because after scanning program, it divided the program into tokens. Yeah, someone is mentioned, tokenizer. Yeah, lexical analyzer, one name is scanner, one more name is tokenizer. He is doing into tokens. Converting high-level language program into tokens or token string or token program. Lexical analyzer, another name is scanner or tokenizer. And one more thing, if you observe clearly, you go to the movie theater, you go to the hotel, wherever you want, right? The first phase is going to be tokens. They will ask, who are you? What purpose you came? Whom you want to meet? What you want to eat? What movie you want to see? Starting only. Introduction, which is also called introduction. You have to introduce. I want this. So tokenizer is the first phase of the compiler, which is also introduction, which is also called scanner. Suppose that someone went to hospital. Listen, someone went to hospital. The first phase, if someone went to hospital, the first thing is going to be scanning. As soon as if anyone join in the hospital, no doctor will do directly surgery. No doctor will do surgery. As soon as someone enter, yeah, right. I think if anyone do like this, it's a serious problem. One patient came inside the hospital. Doctor is already ready with the knife and all to do surgery. Come, I will do surgery. I will cut the body and all. Then no one will go inside that hospital. If anyone come inside the hospital, right, no one will do starting itself surgery. First they will do scanning. Right? Whenever scanning is going on, scanner will identify, oh, it is a reddish or eyes. It is a reddish or left eye. Oh, reddish or nose. Reddish or right eye. Oh, reddish or brain. Reddish or nose. Reddish or mouth. Right? So like that. So Scanner will identify in the body every particle. Scanner will identify in the body every particle. Right? Right? Whenever scanner came here, oh, Reddy sir heart is missing. Oh, Reddy sir heart is missing. Oh, right, Reddy sir may be given his heart to his madam. Reddy sir given his heart to his madam, maybe that is the reason. Right? Reddy sir heart is missing. Right? So it is scanner will identify everything. Scanner will identify everything. Oh, this one, right? Like that. So, right. So, first phase of the compiler is a lexical analyzer, which is also known as scanner, which is also called as right tokenizer. I hope everyone is fine. I hope everyone is fine. Right? Fine. I think madam is behind. Of course, yeah. Otherwise, why I will say this? Madam is seeing from the back side. So when Reddy sir will praise me, right? So she is indirectly checking, right? Will he praise me or not? So I kept a little bit of butter. Little bit of butter I kept. Do you have any problem? Why don't you do your business? Are Hayden, why don't you do your business? Just I kept little bit of butter. Right? Fine. Perfect. Chalo then. Chalo, everything is fine. Everything is fine. So I think people got the clarity. Listen, people got the clarity. Just remember only one thing. Lexical analyzer divide the given program into token. That's it. I said again and again, different ways. I want to convey this information. It will do just two tokens. Some people are thinking, listen, some people are thinking, sir, if anyone go to hospital, starting itself surgery, no, yaar. Starting itself surgery, no. It should be introduction. It should be scanning. It should be tokenization. In every hospital, the first stage is scanning only. If any hospital first stage is a surgery, it is a serious problem. Applying bar ke butter. Okay, that's okay. Can you concentrate on compiler instead of my life? Instead of concentrating on my life, can you concentrate on compiler? Please, my request to everyone, can you concentrate on compiler than my life? Instead of concentrating on my life, can you concentrate on compiler? Bhaiya, please concentrate on compiler. It is also known as scanner because after scanning, program divided into, right? Because after scanning, program it divides. After scanning program, it divides the program into tokens. Yeah, perfect. Now come to the next one. Now listen. Because of your little okay, listen. Because of your little okay, everyone observe. Because of your little okay, right? Observe here. So this is the final output. ID1 is equal to ID2 plus ID3 star 60. This is the output. This is the input to the syntax analyzer. Remember, lexical will do only tokens. You don't do extra. Only tokens he will do. You don't do extra. Lexical analyzer will do only tokens. You don't do extra. Please careful. Means only introduction he will do. Only introduction he will do. That's it. Everyone he will ask introduce like that. Right? This is the input to the syntax analyzer. Is there anyone who knows? Listen everyone. Listen, make sure everyone will listen. Don't worry, you will get it. You will get very easily. Don't worry, everyone, don't worry, you will easily get it, right? So see this, see everyone, this is the grammar. If anyone don't know also, no problem. It is the grammar. It is the grammar. Careful everyone now. Syntax analyzer. Careful everyone now. Syntax analyzer. It is a grammar. So this is the input. Syntax analyzer. This is the input. This is the grammar. This is the grammar. So what the syntax analyzer will try is, whatever input is coming, using this grammar, you will try to create the tree. Let me try. So right, grammar, right, starting from first person. See everyone, S goes to ID equal to E. This ID is ID1. Next one, E goes to, everyone listen, E goes to E plus T. T goes to T star F. Next one, this E goes to T. T goes to F. F goes to ID. F goes to ID. This is ID comma 2. Next one, T goes to F. F goes to ID 3. Next one, F goes to constant, which is 60. If anyone having small doubt also, I will clarify. S goes to ID equal to E. Simply grammar. Whatever given, I written. S goes to ID is equal to E. ID is equal to E. So ID means some identifier. Equal to E goes to E plus T. E goes to T. Simply from this grammar, I created this tree. For this one. Now, it's a very, very interesting question. No need to confuse. It is a very, very interesting question. No need to confuse. Can anyone help me? What is the syntax analyzer output? Can anyone help me? What is the syntax analyzer output? Can anyone help me? Syntax analyzer output. What is the answer? Syntax analyzer output is syntax tree. Syntax analyzer output is syntax tree. Which is also known as parse tree. Which is also called as a derivation tree. Syntax analyzer input is, listen, syntax analyzer input is token string. Output is syntax tree. Just remember, nothing is there. Syntax analyzer input is token string. Output is parse tree, syntax tree, derivation tree. If anyone asking, sir, what is the output this tree giving? Simple, very simple. Leaf nodes, all you read. Can you read all leaf nodes? In this tree, what is the output? If anyone want to know, read all leaf nodes. ID1 equal to ID2 is equal to ID2 plus ID3 star 60. Just read all leaf nodes from left to right. All leaf nodes you read from left to right. Syntax analyzer input is token string. Output is parse tree. So what I mean to say is, for the given input string, you have to draw the tree. That tree should give same token. Whatever token string you have, same thing should come in the tree. So read all leaf nodes from left to right. ID1 equal to ID2 plus ID3 star, right, 60. Star 60. Read all leaf nodes from left to right. That tree is called syntax tree. which is also called a parse tree, which is also called derivation tree. Easily you will get everything, you will get, don't worry. Everything you will get, don't worry. Just I am introducing the keywords. Just I am introducing keywords. Can anyone help me? Can anyone help me? Syntax analyzer, if I, listen, syntax analyzer will create syntax tree, okay, but to create syntax tree, what is needed? Syntax analyzer will create a syntax tree. I am okay, but what is needed for that? I want answer from you. Syntax analyzer will create a syntax tree. I am very happy with that. But to create the syntax tree, what is needed? Yeah, someone is mentioned grammar needed, and one more thing, token string also needed. To create the syntax tree, two things needed. Grammar also needed, token string also needed. Grammar also needed, token string also needed. Grammar also needed, token string also needed. Both are required. Can anyone help me now? Both are required, okay, but token string is given by, listen, token string is given by the programmer. Token string is nothing but a program. This is the program. Token string is nothing but a program. Program, for program only tokens came. Token string is nothing but a program. So syntax analyzer required two things. One is a program, which is called token string. One more is grammar. Can anyone guess from where this grammar is came? Can anyone guess from where this grammar came? Token string is came from program. Syntax analyzer required two inputs. One input is this one. One more input is this one. Two inputs. Syntax analyzer required two inputs. One grammar, one program. Can anyone help me now? Grammar came from where? Remember, grammar means rules. It is a one rule. It is a one rule. It is a one more rule. It is a one more rule. Grammar is nothing but set of rules. Grammar is nothing but set of rules, which is nothing but a compiler. Compiler is the combination of rules only. Compiler is nothing but a combination of rules only. It is compiler. Inside compiler, there are rules. Compiler is set of rules. So what happened is, what the syntax analyzer will do is, with the existing rules, listen, in the compiler, whatever rules are there, using those rules for your program, using the existing rules, compiler internally contain rules, using existing rules for your program, tree possible or not, it will verify. If tree possible, no syntax error. Let me write now. If tree possible, no syntax error. If tree possible, no syntax error. Otherwise, else, syntax error. Otherwise, syntax error. Please be careful. If tree possible, no syntax error. Else, syntax error. That's it. Remember, syntax, right? Syntax analyzer input is two things. Grammar also required, token string also required. Token string means program. Grammar means set of rules. Using the existing rules for the given program, tree possible or not, they will verify. If possible, successfully completed, there is no syntax error. Otherwise, there is a syntax error. Remember everyone. From today onwards, if anyone asks you, syntax analyzer input, simply say token string. Output, parse tree, or syntax tree, or derivation tree. Input is token string. Output is syntax tree or parse tree. This is inbuilt. Rules are inbuilt. You no need to say this. Actually, syntax analyzer require two inputs. One coming from inside. Then no need to mention this. One is coming from inside. Another one from outside. This is the one user one. So syntax analyzer input is going to be a program or a token string. Output is a syntax tree. Suppose isn't that syntax tree successfully created. No syntax error. If anyone don't know grammar and all, in compiler, I don't know. I'm repeating once again. If anyone don't know grammar, in TOC, I explained already grammar and all. I don't know what is the lecture number. After today's class over, I will give lecture number. You have to read 1 or 2 lectures. You have to read 1 or 2 lectures. What is grammar and all. After today's class over, I will give lecture number. In TOC, grammar I already explained. I will give grammar lecture. 1 or 2 lectures I will give. You have to go through it one time. Sir, is that grammar generated also part of the syntax analysis? Can anyone write? In the comment section, can you write? What is compiler? Can everyone write? What is compiler? Compiler is set of rules, which is nothing but everything is, see this one. This is rule number 1. This is rule number 2. This is rule number 3. This is rule number 4. Grammar is set of rules. These all, every production is a rule. Compiler is nothing but set of rules. Every rule is a, right? Every rule is a production. Set of rules. Rule means production. Every production is nothing but a one rule. These are known as productions. Shakir, these are known as production, which are nothing but rules. Compiler, total compiler contain, in my opinion, 1 crore rules are there. 1 crore rules are there, which is nothing but 1 crore productions. Total compiler contain 1 crore rules, 1 crore productions. Now my request to everyone, after today's class over, I will give in your, right? I will give in your group. After today's class over, in your group, I will give TOC lecture numbers. You have to complete them. TOC lecture numbers I will give. You have to complete them. Just only 1 lecture or 2 lecture you have to complete. TOC lecture numbers I will give. In your group I will post lecture number and all. You have to complete 1 lecture or 2 lecture. Right? 1 lecture or 2 lecture you have to complete, so that grammar also okay. Now I think, can you conclude? Can you complete it? Can you complete this one? Lexical analyzer input. Complete fast. Lexical analyzer input. I want only input output. Can you say every phase input output? Every phase input output. Every phase input output. Lexical analyzer input output. Lexical analyzer input. High level language statement. Output token string. Next one, syntax analyzer input token string. Output syntax tree or parse tree or derivation tree. Please remember input output. This is the only introduction. You cannot get everything. This is only introduction. You cannot get everything. In the introduction itself, how will you get everything? Yeah. In introduction itself, how you get everything? Just I am adding 1 by 1. Slowly you will get 1 by 1. Some people are asking, sir, if I want to create a syntax tree, grammar required, na? That is the meaning of compiler. Compiler is grammar. Grammar means rules. Compiler means rules. Rules means grammar. So using the rules, the token string which is coming, can you draw the tree or not? Verify. How to draw the tree? What is grammar? Right? One lecture is there in the TOC. If you study that lecture, you will get the total grammar story. Don't think much. Tomorrow I will give, as soon as today's class over, I will give that lecture number. Before coming to tomorrow's class, you have to read that, you have to come. Fine. Is it okay? Can I move to next? If tree possible, no syntax error. Else syntax error. Can you help me now? Tree not possible. Grammar is wrong or program wrong? Tree not possible. Grammar is wrong or program is wrong? Tree not possible. Grammar is wrong or program is wrong? Tree not possible. Grammar is wrong or program is wrong? Program only, grammar. Grammar wrong means what? Compiler wrong. Who are you to say this? How can you say compiler wrong? When you say grammar, grammar means compiler. Grammar means compiler. So you cannot say compiler wrong. User program only wrong. Using the available rules for your program, I try to draw the tree. Tree not possible. Oh, program is wrong. You cannot say grammar wrong. Grammar is rules. Yeah, right, like that. Can you say from today onwards? Listen, from today onwards, compilation successful. Compilation successful means a tree created or not. From today onwards, compilation successful. Tree created or not. From today onwards, compilation successful. Tree created or not. Tree created. Compilation successful means there is no syntax error. Compilation successful means no syntax error. No syntax error means a tree created. Compilation successful means no syntax error. No syntax error means a tree created. Suppose the syntax error came. Syntax error came. Oh, syntax tree not created. Means in the program something wrong there. Because with the existing rules, with the existing grammar, I am unable to create the tree. If anyone having doubt how to create the tree and all, no need to think that much. After today's class over, I will give one link. Right? In that link, one lecture is there. If you study that, that will also be clear. No need to bother. Compilation successful. Oh, no syntax error. Oh, syntax tree created. Means program correct. With the existing rules, I try to create the tree possible. No syntax error. Means program is perfect. Remember, this syntax tree is the input to the next phase of the compiler. This is the input to next phase of the compiler. Syntax tree is the input to the next phase of the compiler, which is semantic analyzer. Semantic analyzer. What he will do, let me check. Listen, what he will do, what exactly he will do, I will explain. I will explain. Make sure everyone listen. Make sure everyone listen. We'll take input, see the output. Everyone observe, see the output. See the output now. S goes to ID equal to E. Same tree I am taking. E goes to E plus T. T goes to T star F. F goes to integer constant, which is 60. T goes to F. F goes to ID. E goes to T. T goes to F. F goes to ID. This is the ID2. This is ID1. Same grammar, same tree I am taken. I am not done anything. It's the ID3. It is the 60. Now everyone observe. Everyone observe. Everyone observe. No need to think much. Try to get as much as possible. No need to think much. Try to get as much as possible. Can anyone help me? Assignment operator. Assignment operator. What is the left side? ID1. Can you say what is the ID1 type? Assignment operator. Assignment operator left to ID1. What is the ID1 type? It is a token. Using token, can you go and see the table? Using this token ID1, using this token, can you see in the table? Can you see in the table ID1? What is that variable name? What is the type? Using ID1, can you see the table? What is the type? Name is X. Name is X. Type is float. Am I right or not? So using the token, I went to the symbol table. I got to know it is a float. Can you help me now? Assignment operator left is float. You want right also float or not? Assignment operator left is float. You want right also float or not? You will go there. Assignment operator left float there. You will go right also. E goes to E plus T. To do this plus, left required, right required, go left. E goes to T, T goes to F, F goes to ID. Again, it is ID. ID means token number. Can you go in the symbol table? Can you check? This is also a float. Okay, because of it is a float, here also float will come. Same float will come. Here also same float will come. Same thing, whatever is there, it will proceed further. So to do this plus operator, left side float. So right also float required. Remember, in the programming language, one rule there. If you want to do any operation between two variables, both should be same type. Between two variables, if you want to perform any operation, between two variables, if you want to perform any operation, then both should be same type. Same type. Between two variables, if you want to perform any operation, then both should be same type. Can you help me? I want to do plus operation, left already float. Let's go to right. To do this multiplication, left and right. So first left one required, ID 3, it is also float. Because if it is a float, automatically is parent also float. So star operator left float came. But remember, these all types came from symbol table. Now listen. To do multiplication, left float, right also float required, but right is 60. Which is integer. Remember, whether you like or not, both should be same type. Can anyone help? Type conversion done. Listen, left side float or not? Left side expecting float. So it should also convert into float. So this 60 will be converted into float. See how to convert. See everyone how to convert. I'm explaining. Can everyone observe? This is 60. Convert this one. See this one. Float type conversion. Float 60. Then it became 60.0. You done the typecasting. 60.0. It will goes to here. Then it became float. 60, which is the float. Float into float. Float plus float. Float will be assigned to float. That's it. So what I mean to say is, remember, semantic analyzer purpose is type checking. Someone should be there to take care about types. Until now, I am not taken care. See, in all the pages, nowhere I taken care about types. See, lexical analyzer, only tokens. Lexical analyzer purpose, tokens only. Only tokens. His goal is tokens. Next one, syntax analyzer, only tree. Syntax, he will take care about syntax. Semantic analyzer, type checking. He will take care about types. Type checking. Now, someone is saying warning will come. Of course, when you listen, everyone, now if you convert the smaller one into bigger one, warning will come. If you convert a bigger one into smaller one, error will come. When you try to convert bigger one into smaller, you will lose data. Then you will get error message. Smaller size to bigger size. So integer is 2 bytes, float 4 bytes. 2 bytes if you store in 4 bytes, right? You don't lose anything. Space will be more, right? Warning will come. This is called implicit typecasting. Exactly. So remember, semantic analyzer purpose is a type checking. See, left side is float. Then I want everything is float only. See, float. It is also float. But it is unfortunately integer. Integer constant. Right? So do typecasting, it became float. So finally float came. Float plus float again. Next one, float into float, float again. So like that it is happening. Some people are asking, sir, why are you converting? See the rule between two variables. If you want to perform any operation, then both should be same type. Then both should be same type. Between two variables, if you want to do any operation, then both will be same type. Then both will be same type. Purpose of semantic analyzer type checking. Now it is the correct time to ask you. Listen, it's the correct time to ask you. Everyone observe. Everyone observe. It's the correct time to ask you. It is the correct time to ask you. Semantic analyzer input. It's the correct time to ask you. Semantic analyzer input. Make it fast. Semantic analyzer input. Syntax tree. Output. Output also syntax tree, but a modified syntax tree. See, somewhere little changes are there. See, output also syntax tree. Somewhere some changes are there, little bit, which is also called as modified syntax. Little bit modification. Modified syntax. Little bit modification. Yeah, he will verify semantics correct or not. Can you say out of all these three people who bother about, listen, out of all these three people who bother about types? It is a very important question. It is a very important question. Out of all these people, who will take care about types? Who will bother about type? Out of all these people, who bothered about types? Someone is saying annotated syntax, afterwards we'll see. Yeah, people, whatever you are saying, that is also correct. Can you help me? Out of all these three people, who will bother about types? Everyone. Who will bother about types? Out of all these three people, who bothered about types? Semantic or not? That is the reason. Listen, that is the reason. Now see this one. That is the reason. Everyone listen. That is the reason when our declaration came, those types will be stored by semantic analyzer inside. That is the reason when our declaration is came, those types are stored by semantic analyzer, because semantic analyzer only want types. Semantic analyzer only want type. You only want type, so you only will store. Be careful. If anyone asks you why semantic analyzer is storing types inside, you only want it. Whoever want, they only will store. Who is using types? Semantic analyzer. So you only will store. See, if I want, I have to store. Semantic analyzer want types. When our declaration, semantic analyzer will come to the picture. Declaration means immediately semantic analyzer function will be called. It will be stored inside symbol table. Until now, few people are having doubt. Why declaration semantic analyzer will store? Why, sir? You needed, na? You only will store. Whoever needed, he will store. Who is using type? Semantic. So you only stored it. Is it fine? Is it fine? Is it fine? Whoever want, he only will do. Perfect. Yeah, fine. Now observe. See this. Remember everyone. Because you want types, you only will store it. So only variable type is stored by semantic or entire table. Only variable type is stored by semantic or entire tables. See, whenever a declaration comes, just remember, right? I think hidden, don't think much. If anything is there, I will let you know, right? As of now, when our declaration will come, semantic analyzer will come to the picture. So he will store inside. Now listen. Now listen once. One small story there. Listen. One small story there. Everyone listen. When our declaration there, semantic analyzer will come to the picture. He will store inside a symbol table, because declaration only will say what type who. Declaration only will say what type who. Be careful. Declaration only will say what type who. Right? Be careful. So I'm doing. So now see what happened. Let us assume. Everyone observe. Let us assume declaration not there. Everyone listen. Let us assume declaration not there. Okay, declaration not there. If declaration not there, symbol table empty. If declaration not there, symbol table empty. If declaration not there, symbol table empty. Everyone know. Because of see this one. Because of declaration, symbol table contains some values. Now no declaration. Now see what happened. Because of lack of declaration, semantic analyzer don't store. Now see what happened. Directly this line is came. Directly this line. Let us assume that no declaration. Directly this line is came. Now see the first line. X is came. Lexical analyzer is asking, hello X, can you introduce? X said that I am an identifier. Lexical analyzer is saying, if at all you are identifier, you should be there in the symbol table. If at all you are identifier, you should be there in the symbol table. Let me check. He verified. He got to know. Lexical analyzer is verified. He got to know he is not there. Lexical analyzer got to know that, right, this X is not there. Oh, this X is not there. Oh, it is undeclared variable. Declaration not there. But remember, lexical analyzer purpose is only tokens. He know his business. Very well. Lexical analyzer got to know that X is the identifier, then he should be there in the symbol table. He went and he verified inside the symbol table is no more. Then he got to know that lexical analyzer, oh, X is missing. So, X is not declared. That's the reason this problem. So it is an undeclared variable. You want to give error message. But immediately remember, my goal is only tokens. My goal is not other things. My goal is only token. Then what the lexical analyzer will do is, because it is not his work, what he will do is, he want tokens. To proceed further, he want token. Then what he will do is, he will store inside the table, he will store X somewhere. Token number is given, first row is stored, ID1 he will give. Because of you don't know type, he will keep gap. He knows that it is an undeclared variable, but it is not his work. Because his goal is only tokens. Token purpose, whatever needed, he will do only that. Other things you don't care. Sometimes in your life also, right? So something happening which is not belongs to you, you will keep quiet. Somewhere, because you are in the society, there are so many good things may happening, maybe bad things are happening, good things, whatever it is. But sometimes you will see, you don't react because it is not your work. So in the similar way, lexical analyzer also got to know that X is not declared. Oh, it is an undeclared variable. You want to inform to error handler, hello error handler, X is undeclared variable. You want to inform. But error handler saying that, are lexical, you do your work. You don't give unnecessary complaints. What is your goal? Tokens. Do tokens, na? Why you care about other work? Other people work, why you bother? So then what the lexical analyzer will do is, because of he want token number, he will store that one somewhere in the table. But type you don't know, he will keep gap. Then he will say token number is ID1. In the similar way, Y came and Y is saying identifier. So again he will go inside the symbol table, is not available, is undeclared variable. You want to give error, he informed to error handler. Error handler said, do your business. Your business is only tokens. So he will control, he will store Y somewhere, type as a gap. So token number is ID2. In the similar way, Z also. ID3. Now see what happened. Interesting answer. Now see what happened. It is a Z, it is a gap. So because of the first phase of the compiler, some things he will see, but he don't react. Because his goal is only tokens. He can do. But if he do, what other phases will do? Everyone having their work. His goal is only token. If any other thing happening, right, he will just control. You don't do unnecessary work. Now see what happened. Listen. Now see what happened. Everyone observe. Everyone observe. Semantic analyzer is going on. Listen, interesting answer. Semantic analyzer is going on. ID1. E need type. Everyone listen. Semantic analyzer is going on. E need type. Type purpose, you will go symbol table first row. Type purpose, you will go symbol table first row. In the symbol table first row, there is a gap. In symbol table first row, there is a gap. You got to know, what is the answer? Undeclared variable. X is an undeclared variable. Because of gap is there, you got to know undeclared variable. Remember, semantic analyzer will do type checking. Semantic analyzer will do type checking. He will give two kind of error. One error is undeclared variable. One error is undeclared variable. Type checking you will do undeclared variable because something related to type only. You want to know type event there, type not there. Oh, undeclared variable. Now see one more interesting answer. One more interesting answer. Can you see the one more interesting answer? Everyone listen this also. Everyone listen this also. Into, careful. Int x, y, z. Whenever you say int x, y, z, whenever you say declaration int x, y, z, x integer, y integer. See this one, z integer you store. Unfortunately, you written one more line. Unfortunately, written one more line. Float x, y, z. Already x is into. You written float also. Like semantic analyzer first tried, he stored everywhere. Semantic analyzer tried to store this also, but already x is a into. Again, you are saying x is a float. You got to know that, oh, same thing you are declaring two times, multiple declaration error. Multiple declaration error. Remember something related to type. He will take care. One error is undeclared variable. One more error is multiple declaration. Multiple declaration error. Is it fine? Undeclared variable, multiple declaration error. Undeclared variable, multiple declaration error. Is it okay? Semantic analyzer, type checking, undeclared variable, multiple declaration error. Syntax analyzer, syntax purpose. Syntax analyzer, syntax purpose. Lexical analyzer, tokens purpose. Remember, everything can be done by everyone, but there is some controlling. You can study UPSC also. You can study NEET also. You can study IIT JEE also. You can study GATE also. Whatever is your work you are doing GATE. Right? You can study. It doesn't mean that you cannot study other. But what is your assigned work? Do that only. What is the assigned work? Do that only. Fine? Is it okay? Let me know if anyone having doubt. Small doubt also there, let me know. Make it fast. Anyone doubt? Small doubt also there, please let me know. Yes, exactly. How you declared accordingly. How you declared. So if you declare static area, it will store. It will. If you declare normal stack area, it will store. Right? If you say malloc, right, heap area, it will store. It depending upon how you done this. It depending upon how you done this. Right? Let me know any small doubt also there. Let me know. Any doubt? Yeah, very good doubt. Very good doubt. Some people are asking how semantic analyzer came first, how lexical came second, how you may do like that. Remember everyone, it is a program. Anytime anyone you call. Lexical analyzer is a one function. Semantic is a one function. Syntax is a one function. Anyone called anytime depending upon requirement. There is no compulsion. You should only do first. You should only do second. Everyone will do. There are functions. Yeah, they are functions. There is no systematic approach. If you want to give order, listen. If you want to give order, this is the order. If anyone asks you in which order, listen. If anyone asks you out of all these people, can you give one order? Can you give one order like this? Like this. I can give one order like this. But who, right? What about execution? While running, anyone call anyone. While running, necessary place, call necessary person. While running, necessary place, call necessary person. Is it okay? While running, call necessary place, necessary person. That's it. After all, they are functions. After all, they are functions. Please try to understand. After all, they are functions. Please try to understand. Let me know if anyone having small doubt. Fine. Sir, if we take at a time different variable type, then sir, so you cannot take, na? Different variable you can take, no objection. See, different variable, different types. What is the problem? See, same person cannot come two different types. Same person cannot come with two different types. Sir, if you call semantic first, then it should, right? So that's what I'm saying. By seeing declaration, Sai remember. By seeing declaration, immediately semantic is called. By seeing declaration, immediately semantic called. Now my next question to everyone. Who will store inside symbol table? I want answer. Who will store inside symbol table? I want answer from all of you. Say everyone. Inside symbol table, who will store? Anyone. If declaration is there, semantic. If declaration is there, semantic. If declaration not there, lexical. Are you getting? If declaration is there, semantic. If declaration is not there, lexical. Yeah, someone is saying identifiers are stored by lexical also. Sometimes lexical will store. Sometimes semantic will store. That is the reason best answer. All can store. Best answer. All can store. Yeah, but lexical will store without type because you don't want type. You just want in which row X there. Lexical analyzer want to know X there, which row, but he is not there. He will store somewhere, he will take row number. If there, he will take the row number directly. If not there, he will store somewhere. He will return the number. Anyone can store. If anyone is, if at all, if question is symbol table, who will store? Everyone. If any option there, everyone, select everyone. If any option there, everyone, select everyone. Suppose everyone is not there. Everyone is not there. Right? Lexical, syntax, semantic. Lexical, syntax, semantic. Say, take like that. Suppose those three also not there. Lexical is there, semantic is there. Take lexical, semantic. If those two also not there, only lexical, take whichever available best. That one you take. Actual answer is all. Actual answer is all. Whoever better, take it. Normally types semantic required. Suppose declaration not there, semantic cannot store. But lexical saying that I want token number. So he will store forcefully without in the place of type, he will keep gap. Fine. Any doubt? Yeah, fine. Any small doubt also let me, sir, but lexical will store without type. Yeah, perfect. If you okay, I can move to the next one. Can we move next? Everyone can store, but remember the functionality. See, lexical is only tokens. He can do, if some people are saying undeclared also he will do. Some people are saying undeclared also he will do. Multiple declaration also he will do. Some people are saying everything he will do. What semantic will do? Some people are saying because of he is the first person, right? He only will do declared. You only will do undeclared. You only will do multiple declaration. If everything you will do, semantic will file a case on the lexical. Semantic will file a case on lexical. You are doing everything. My work also you are doing. My work also you are doing. Right? What I will do? Then I will also do tokens. Semantic will say that I will also do tokens. You are doing my work, I will do your work also. You are doing my work, I will do your work also. So careful. Right now see this one, because of you are absolutely fine. Right? I think see until now, listen, until now no problem there means, until now no problem there means, right? They got to know that everything is perfect. Until now no problem there means everything is perfect. Now you will take the actual thing. What is the ID1? Because of everything is fine now. What is the ID1? ID1 is X. What is the ID2? Y. What is the ID3? Z. Right? This became 60.0. It became 60.0. Now see what will happen. Because of everything is fine, they got to know no syntax error, no syntax error, no semantic error also. Something related to types, semantic error. Something related to syntax like semicolon missing, bracket missing, those are called syntax. No syntax error, no semantic error means program is almost like perfectly fine. No syntax error, no semantic error means program is almost perfectly fine. Now we have to do the conversion, because compilation purpose is high level to low level. Now let me concentrate conversion. From now onwards, conversion will happen, right? Now see conversion, intermediate code generator. Listen everyone now, conversion, intermediate code generator. Intermediate code generator. Intermediate code generator. Everyone observe. Intermediate code generator. Careful now. Intermediate code generator. You only say multiplication and addition. Multiplication is highest priority. Can you see this one? Multiplication highest priority. So T1 is equal to Z into 60.0. It should be done first. Multiplication and addition. Multiplication highest priority. So this will be done in one temporary variable. That is the reason it is called intermediate code. Intermediate means temporary code. Temporary code, intermediate code or a temporary code. Z into 60.0, which is the T1. Next one, T2, if you observe, Y plus T1. This is the T1. Y plus T1, which is T2. It will be done in one more temporary variable, T2. Lastly, X is equal to T2. This is called intermediate code, because you are using some temporary variables. You are using some temporary variable. This is called intermediate code generation. Because you got to know everything is fine, they will take the actual expression. Now they will try to convert, because purpose of compilation, high level to low level. So before this, what we done is we are not converted. We are verifying program correct or not. If program correct, I will convert. See, from here onwards, conversion will start. From here onwards, conversion will start. Conversion will start. Because program perfect. Conversion from high level to low level. Because you got to know program perfect. See, no syntax error, no semantic error, means program perfect. Now concentrate on conversion. First to do multiplication, next to do addition, that will be stored. This is called intermediate code generation. This will be input to code optimization. If possible, minimize. If possible, minimize. Some people are asking, sir, how will you minimize? Very simple. See this one, T1 is equal to Z into 60.0. First to do multiplication. See everyone, first to do multiplication. Okay, I done multiplication. With that multiplication answer, Y plus T1. Add Y plus T1 will goes to T2. That T2 will goes to X. Why don't you store directly X only? If possibility there, do optimization. Why are you storing result into T2? Finally, T2 will be stored in the X. Why are you unnecessarily expanding? Why don't you optimize? If possibility there, optimize. Okay. Lastly, this is going to be target code generation. This is going to be target code generator. Lastly, you want low level language statement. So everyone know low level language statement. Everyone know. See this one. See everyone. Multiplication means mul. multiplication mul. Lastly, addition add. One addition operator. Add is there. Lastly, if you want to store in the X, you can store, maybe store or a move, whatever it may be. It is not important. Just write some rough idea. So one every line you will see one operator. Multiplication R1, R2. Addition, maybe R3, R4, or maybe, right, you can say R3, R1. Lastly, R3 will store maybe here, something like this. Don't worry that much, right? Roughly I given the answer. Roughly. Isn't that store operation, right? Store operation, R3 will store in X. Direction I am giving. Book to book direction will change in the anyhow. In the CO, you will see that. Store X comma R3. R3 will store in X. Target code means mapping. So listen everyone, multiplication there. So mul plus is there. So add. Like that they will do mapping. Because of it is not important, so I am not saying right clearly, not required. Simply target code means final target. Assembly language, yeah, of course. Assembly language. Just map. Oh, first line multiplication operator. Mul. Second place addition there. So add. Now, one small question I want to ask you. Listen everyone, one small question. It is the main road. It is a road. It is a national highway. Everyone listen. It is a national highway. Careful everyone. It is a national highway. Your car is going here. Your car going on the right side. It is a national highway. This is the way how you are going, right? Your car is there on the right side. Let us assume you want to go left side. How will you go? It is a national highway. Your car is going on right side, but actually you want to go left side. Can you say how will you go? You are going right side, but you have to go left side. How will you go? Will you go directly or will you go middle first? You are there on the right side. You want to go to left side. Will you go directly to left side or will you go intermediate? Make it fast. You are there on the right side. You want to go left side. Will you go directly to left side or intermediate? Go middle first. So similar way. High level to intermediate. Intermediate to low level. High level to intermediate. Intermediate to low level. This is the low level. If possibility there, see, if possibility there, optimize. If possibility there, optimize. Code optimization. If possibility, sometimes optimization may not be possible. I have a minimal DFA. If I do optimization, I may get same. Minimal DFA already I have. If I apply minimization algorithm, I will get the same thing again. I cannot give guarantee every time optimization possible. Code optimization may be possible, may not. If possible, optimize. If possible, optimize. If not possible, keep as it is. Fine. Some people are asking, why are you going high level to? If you want high level to low level, go high level to low level directly. Na? Don't do anything in life directly. Don't do anything in life directly. You want to go from high level to low level. Go high level to middle first. Middle to low level. That is the reason if you want, you can verify. After summer, listen, after summer, directly, winter will not come. After summer, right, I also identified, after summer, directly winter will not come. After summer, in between, raining will come. Raining season will come, then winter will come. Summer followed by raining season followed by winter. Suddenly summer become winter. It is not possible. It is not good for health also. Humans cannot digest it. So high level to middle, middle to low level. And remember first three people. First three people successful means lexical successful. Syntax also successful. Semantic also successful. These three are over means program don't have any fault. This is checking purpose. These are checking purpose. This is for conversion. Intermediate code, code optimization, target code. These are for conversion. Because I want to convert from high level to low level. This is for conversion. This is for checking. First verify program correct or not. If program is correct, then convert. Program not convert. Program is not correct. Then give the error so that user can change it. If the program is not correct, then give error so that right programmer can verify, can change the code so that until everything is correct. Remember, valid program only convert. Don't convert everyone. Valid program only convert. Valid program only convert. This is the entire story. I hope you got. Initially, you have many doubts. Now you may not have any doubts. Today's class started from here. Today's class started from here. Today's class is started from here. Sir, please take classes on Saturday, Sunday also. In this way, syllabus will be completed fast. What is the use? If you complete fast also, what you use? You have to write the tests. Saturday, Sunday, write the tests. Completed subjects, write the tests. Otherwise, you will forget the completed subjects. Right? So not only syllabus completion, right? You should write the tests also. You cannot forget the previous things. You cannot, right? You cannot forget the previous things. Almost 8 subjects or 9 subjects are over. 8 subjects or 9 subjects are over. Please do it fast. Whatever completed, please do it fast. Please write the tests. For every test, please practice and come. For every test, practice and come. If you do that simultaneously, both will be done. Yeah, of course, that is a plan. That is a plan. Right, very soon one more will start. Let it go a few days. In between, one more will come. Is it okay? So I started today's class with this. Then I took one example. I explained what the lexical analyzer will do, tokens. Right? So what the syntax analyzer will do? I think a parse tree creation. What the semantic analyzer will do? Modified parse tree. It will create the modified parse tree. Someone is saying that annotated parse tree. If you want, you can write decorated parse tree. Decorated parse tree or annotated parse tree. Right. Now, these 3 people are successfully completed means there is no error. These 3 people successfully completed means there is no error. Now start conversion. Because of no error, previous thing successfully completed means no error, then start conversion. Conversion from high level to low level. Conversion from high level to low level. Right, so I started conversion. So please write every test. The people who are saying to me complete syllabus fast, please can you write the tests? Arey Aditya, I didn't see one test also from your side. Don't you write test bootle? I didn't see one test also from your side. You are not writing any test. You are not writing one test also. One test also is not written. You don't write test or what? You will forget the previous things. Whatever you studied previously, you will forget it. Please write the test. At least from now onwards, start. Aditya, at least from now onwards, start. Yeah, tomorrow I will explain. Fine, I hope you are okay. In tomorrow's class, we will see this. Further story we'll see in tomorrow's class. Can we stop now? Fine. Write, start write the test. Everyone start writing tests. Everyone start writing tests. Can we go next? Okay, fine. Yeah, you just assume that morning class is there. Assume that morning class is there. You yourself open the Zoom and do puja. Open the EPT. Open the EPT. Do puja. Chalo then. See you tomorrow.